Right, here's another think, pair, share, again with two population means where the population standard deviations are unknown, but again where those population standard deviations are assumed to be equal, sample standard deviations are uh, relatively within this similar magnitudes, and sample sizes are approximately equal and they're considered small. So the average number of chocolate chips per cookie in two competing brands were studied. Assume the population of the number of chocolate chips per cookie is normally distributed and the population standard deviations are equal. Makers of brand A claim their cookies average more chocolate chips than brand B. Test this claim at a 95% confidence level. Okay. All right. Once again, I'm sorry. My computer is it's pausing. Oh, here we go. Okay. So step one, let's look at our given information. Um, so brand A will make that number one, and brand B will make that number two. So sample size one, we've got sample size two, average number of chocolate chips per cookie. So that's going to be our X bar one. This will be X bar two. Sample standard deviation, so this will be S1 and S2. Um, let's see here. So the population standard deviations are assumed to be equal. So that means that we are going to have a pooled standard deviation. So pooled is going to be yes. Um, let's see here. Both our sample sizes are less than 30, so they're considered to be small. Now let's look at this claim. So claim brand A, their cookies average more than. So the population mean for brand A is greater than brand B, mu2. And that is our original claim. We're dealing with a confidence level of 0.95, which means we're going to have a significance level of 0.05. All right, and even though these are considered equal, they are unknown. And so because they're unknown, we have to use the student's t-distribution. Okay, my computer is frozen again. Okay, student's t. All right, so I think that's everything that we need for step one. So let's see here. Step two is going to be to set up our null and alternate hypothesis. Okay, so we have one of our hypotheses here, mu1 greater than mu2. That is our original claim. And the complement to that is going to be less than or equal to. Because it's equal to, that's going to be our null. The other ones are alternate. And the alternate tells us the direction of the distribution tail. And that's going to be right-tailed. Again, it's right-tailed because if we make an arrow out of this inequality, it looks like it's pointing to the right. All right, step three. This is to calculate our t-test statistic from our sample data, as well as our p-value And because we're dealing with a student's t, we need degrees of freedom. So we'll get that calculated as well. All right. So we'll do a two-sample t-test, and let's see, x1 is 6.4, s1 is 1.1, n1 is 10, x bar 2 is 5.6, s2 is 1.7, and n2 is 11. And our alternate hypothesis is greater than m2, and yes, it's going to be pooled. All right. For the numworks calculator, again, okay, computer is paused. Okay. Here we go. So we're going to have, let me just do the algebra here. So we have mu1 greater than mu2. Subtract mu2 from both sides. That'll add up to 0. So we have mu1 minus mu2, carrying that down, greater than 0. So this is going to be the sign of the alternate hypothesis that we're going to use. Just make sure that 0 has been input here. All right. And let's see, we're going to put in the same values into the numworks calculator. So x bar 1 is 6.4, s1 is 1.1, and 1 is 10. X bar 2 is 5.6, s2 is 1.7, and the sample size of the second sample that lets me scroll down is going to be 11. Oh, wait, I need standard deviation. Okay, 1.7, 11, significance level of 0.05. All right, so let's go ahead and put that information in the two-sample t-test. Okay, let me clear that. So I'll hit stat, go to tests, go down to two-sample t-test. Okay, we want to input statistics. So here, x1 is 6.4. This is 1.1. And 1 is 10. X bar 2 is 5.6. S2 is 1.7. N2 is 11. And we're going to have an alternate hypothesis of greater than. And pooled, we want to put yes. Okay, let me leave that up. Let me back out here. Okay, I'm going to go to the inference app, do tests. Okay, this is with two means, and we want to do a pooled test. All right, so we have mu1 minus mu2 equals 0. And then this one is going to be greater than for the alternate. Okay, we're going to input statistics. And x bar 1 is 6.4. S1 is 1.1. And 1 is 10. X bar 2 is 5.6. S2 is 1.7. N2 is 11. Okay, 5% significance level. Hit next. Okay, there's our t-test statistic, our p-value, and degrees of freedom. Let's corroborate that with the Texas Instruments. And it looks like we're getting the same values. All right. So let's go back. So we're going to have a t-test statistic of a positive 1.2 265, a p-value of 0.111, and degrees of freedom equals 19. All right, let's go to the next page. Okay, and this will be step 4, but let me go ahead and write what I am carrying over from the previous page. P-value and degrees of freedom equals 19. Okay, so this is where we're going to sketch our distribution and calculate the t critical value. So let's draw our student's t distribution with a center of 0. And let's see, we said that this was going to be right-tailed because of our alternate hypothesis. So we're going to have a positive t critical value. This area in the tail adjacent to the critical value, that's a significance level. Okay, the region over the tail, over the significance level, is reject the null. The other region is the fail to reject the null. Okay, we're going to have an area of 0.05 with 19 degrees of freedom. And numworks, 19 degrees of freedom, area to the right of 0.05. So let's do that. So let me quit out of this. So when I look at the distributions, I need to use inverse t. Okay, I want an area of 0.05. Now with 19 degrees of freedom. Okay. Okay, this is showing a problem that we have with the inverse t. All right, so we're getting a negative 1.729. Now, the reason why we're getting a negative 1.729 is, remember, this calculates area from the left. So had we been over here and we had this area, we would have had a negative t critical value of negative 1.729. Okay, because this function only calculates area from the left. All right, but in truth, because we've drawn it out and we know that it's right-tailed, we should have a positive t critical value. So it's going to be a positive 1.729. All right. Sometimes it can be difficult to remember that. So this is one of the reasons why I went ahead and wrote this program, inverse T83, because it's going to ask for the same values. Okay, but you can say I want the area on the right tail. And it gives us a positive t critical value of positive 1.729. And it kind of confirms, it tells us the right-hand tail. Okay. All right, so we got that. Let's look at the numworks calculator. So let's go ahead and back out of this. Okay, now we want to go to the distributions app. We want to go to students T. We want 19 degrees of freedom. We want the area on the right. And that area is going to be 0.05 or 5%. So we get a positive 1.729. So we get a positive t critical value of positive 1.729. So, it's really instructive to put all this in here, and I'll explain why here in a minute. It'll become evident in a second. All right, so let's go ahead and put our test statistic in. So our test statistic is positive 1.265. So 1.265 is greater than 0, but it's less than 1.729. So maybe somewhere right about here. So this is our t test statistic of positive 1.265. And if we draw up from that, that's clearly indicating that we're going to fail to reject the null, and that this area right here, that is our p-value, and that's 0.111. Now, the reason why I said it was important to remember that this is right-tailed, because imagine if we had made the mistake and used this value. I guess it would have given the same. It would have given us the same answer in this case. It's not always true, but in this case, it would have given us the same answer. You know, this value being above this one would have put us in this fail to reject region. So this would have been okay, but you just have to be careful with this, okay? It worked out this time, but it may not work out all the time. All right, so comparing apples to apples here. Okay, my computer froze. Yeah, just waiting on my computer. Again, I think it's this Word document. It's just so large and it's got so much handwritten text. I think it's trying to update all of it. I don't think I have this set to autosave. Might have to check that because it could be auto-saving, and when it's auto-saving, it's pausing things here. I may have to turn auto-saving off so it doesn't do this anymore, but I'll have to check it. We'll see. All right, computer is still frozen. I apologize for the delay. Okay, and we're back. So if we compare apples to apples, so values on a number line, okay, that's telling us we're failing to reject the null. And if we compare oranges to oranges, okay, if the p-value is smaller, reject the null. But you can see that the p-value is not smaller, it's actually greater. So that is pointing towards failing to reject the null also. So step 5 is to write down our results and form our conclusion. So we ended up failing to reject the null. And I believe the alternate, if you look on the previous page, the alternate hypothesis was our original claim. So we can come down here to our handy-dandy conclusion table. All right, so we're going to fail to reject the null, and the alternate was the original claim. So we come over and down. This is the outcome we're going to write in our conclusion. So there is not sufficient evidence to support the claim that the average number of chocolate chips per cookie And brand A is significantly greater than brand B, and that is with a 95% confidence level. And there we have it. All right, let me know if you have any questions.